Hello, welcome to the Big Strategy Podcast. I'm your host and fellow strategist, Jeff Hyatt. This is your go-to spot for real talk with the masterminds of business strategy. It's about sharing stories, insights, and those little nuggets of wisdom to help you unlock big growth. Let's turn the key and spring into action. Welcome, everyone, to this episode of the Big Strategy Podcast. I'm your host, Jeff Hyatt, and honored to be joined today by Eric Siegel, the CEO of Gooder.ai. Beyond being a thought leader in the space, as taking that wisdom and putting it into action. And we'll talk a lot about that today as we continue this season of the podcast, looking at AI implementations and real world use cases. So, Eric, we're on different sides of the bay, but connected by technology. So it's great to have you on.
It's great to be here. Thank you, Jeff.
Thanks. Well, just kind of kicking us off, I like to just ask folks, when was your aha moment in AI? And if you choose to differentiate machine learning, because I know that's so important to what you do.
Well, sure. I've been in the field of machine learning for more than 30 years. Basically, since the end of college, I went straight into grad school, got a PhD at Columbia. I was a professor in the computer science department, teaching the grad school course in machine learning at Columbia. And I've been an independent consultant for more than 20 years, and now the founder of Gooder.ai for almost 2 years. So there were sort of a few phases. When I was a kid, I got really enthused about AI. I had a relative who was a philosophy professor and a computer enthusiast in the late 70s. And he became my pen pal, the Turing test, all that stuff. So I became enamored with it. Flash forward to now, and I'm actually really tempered by the concept of AI. I think that the term in general tends to oversell, and that we should describe technology in concrete, specific terms that are credible, especially in terms of their actual value proposition, how they deliver value, rather than quality like intelligence, which is nothing if not a description of human capabilities. So I think we get a little bit lost in some dreamlike state and excitement. And yet at the same time, I do think generative AI is the most amazing thing I've ever seen. So it's a funny balance. I don't think we're quite striking it that well. But what we're doing at Gooder.ai is very much about focusing on the concrete value and measuring that value.
Nice. I like to think if you can replace the word AI with fairy dust or a magic wand, it may not be descriptive enough.
Yeah.
We just put some fairy dust on our software, and amazingly it works. So for those, very simply, just give us a 30-second, what's the difference between machine learning and AI, and why did you choose machine learning when you got into this?
Machine learning is a well-defined field, concept, value proposition. It's learning from data to predict. So data encodes a collective recording of the experience across an organization or the whole world. So which customer defected, which machine in a factory broke down, and which word came next in this big written manuscript, right? So all of these kinds of data are experience or example cases from which to learn. So the same core technology, machine learning, powers all different kinds of use cases. And the two main broad kind of categories of use cases are called generative AI and predictive AI. But under the hood, they're both fueled by the same category of technology, which is that machine learning technology. And the idea for a computer to learn from experience, that it's to draw generalizations, patterns, formulas from some list of previous examples that then apply well and pan out over new, previously unseen, unique cases is such an astounding, sort of philosophically interesting thing. And the technology is really cool and it works. We know it works. So that sort of abstractly, I've always been enamored with the field. It's really been pumped up on steroids with what it can do now with generative AI. I'm very much enamored with large language models. When I was in grad school, I was within the natural language processing research group for 6 years of my life. And I never thought I'd see what we do see today as far as the capability of the system to really see. It's so seemingly human-like. It's clearly capable of certain kinds of reasoning. It's clearly capable of having captured some sense of the meaning of words, phrases, paragraphs, and documents. Now, that doesn't mean it's doing the same thing that humans can do, or that it can achieve the same general capabilities of humans. So there's these two thoughts I think are really important to hold in your head at the same time, and that I think the world is failing to do so, which is, that's amazing. It's unprecedented, unexpected by most of us, really, truly astounding, and very valuable in many ways. And yet, that doesn't mean it's approaching general human level capabilities. And I think that that's the main misconception that fuels the hype about AI in general, is this narrative that we're around the corner from what they call AGI, artificial general intelligence.
Right, right. And that's a lot to unpack. Thank you. Very well said. Machine learning has been around for some period of time, but it's a transition to LLMs that's really been magical in the terms of, if nothing else, making it approachable to a broader.
Yeah. Well, I mean, by definition, it's easy to use for anyone because it operates with human languages like English.
Right. And this is my famous story, is my computer science career ended when I failed freshman calculus. But today, right, if you're programming in your native language, English, you can literally program in just written English. And oh, by the way, the machine can help you be a better programmer by asking better questions before you even write any code. This may be too hypothetical, but does it advance that because the underlying technologies of these LLMs are neural networks based on the structure of the neurons in the brain? Should we have seen this coming, that it would have human-like capabilities just from that fundamental structural level, or was there more that had to be done?
No, I don't think that the astounding capabilities come out of what we really should just call an analogy to the human brain. So neural networks are a misnomer, as are many things in technology. It's basically a neural network. Yes, it's a network of neurons. Each one's a very simple, basically nonlinear formula. But it starts with linear formula. So each little node is just a weighted sum. But if you have a network of those, which basically amounts to just a weighted, when you say network, that means it's a bunch of nodes with arcs connecting them, right? So it's just a way to visualize what's basically just a complex mathematical formula. So by making a network, you're combining them. A combination of linear combination with just a weighted sum ends up being another weighted sum, not capable. But if you add a little sort of nonlinear twist, like literally what they call a hockey stick, so instead of a line, it's got a bend to it at a certain point, that makes all the difference in the world. But this is just a way to formalize both what's been learned in terms of the weights that are on all these little arcs between connecting the nodes, the weighted sums, if you will, and to formalize exactly, well, how do we train it? How do we adjust those weights? How do we keep adapting it incrementally, changing the weights according to what that data from what you're learning that I mentioned? That's the definition of machine learning. You got a bunch of labeled examples, cases where you already knew the outcome, you know what word came next in this document, you know which customer canceled. So it's got all those example cases. That's why it's called supervised machine learning. It knows the right answer for this maybe very big but limited number of learning cases, what's actually called the training data. And so you need to have some way for it to be adjusting the weights, and that's called backpropagation because it sort of trickles backward through the network, giving negative reinforcement depending on the magnitude of the error at each point. And that works. But the fact that you could compare it to the way neurons in the brain are connected, that's at least controversial. I subscribe to the camp that it's basically irrelevant. It's such a simplistic, broad, just call it an analogy to the human brain rather than a replication of it. Calling it a neural network is a marketing pitch, right? But it's a really, really good machine learning method.
Indeed. And I appreciate you calling that out, because that is why, very simple, a model is not open if you don't know the weights. And you may not have to pay for the model, but at the end of the day, if you can't adjust those weights or don't know what those weights are, then it's not open. And that truly is the value in this entire space, in my opinion.
Yeah, I mean, it's a whole new world now where we have proprietary models because, as you say, you don't know the model if you don't know the weights. Literally, the model is defined by the weights. The weights are that long list, that very large number of weights. That is the model. That defines the model. And before generative AI, most uses of machine learning were what we now call predictive AI, or you could call it predictive analytics. That's the name of the first of two books I wrote, actually. And in those cases, the general paradigm was that an organization would create their own model on their data. You have your own particular set of prospective customers or factory equipment that might fail, train wheels that might fail, satellites that might need a new battery, whatever it is you're trying to predict. You've got that customer list, whatever it is. So you're going to train a model over your particular data, and that way create a customized model that's attuned to your particular value proposition, the way customers respond to it or don't, et cetera. Very much specialized model for your particular business use case on your data that reflects your business and the context and all that. So very much customized. But with generative AI, where you've got models that are sort of universally used across organizations for writing, for generating content, and all the different applications of generative AI, that's different. Now, all of a sudden, we've got models that are much more hairy, complex, huge, and also more universally used and shared across organizations. So then we have this big, newly important question, which is the model open? And that's another religious debate, right? I mean, you've got Meta releasing and many parties releasing these open source, so-called open source models. And that means you literally have all the weights. So if you have a computer, in principle, you can run the model all by yourself and you have complete access to it.
You're right, and I've set up an LLM on my machine just so I have an AI when I'm flying. But it's just the principle of it, I think, is just beyond anything I've ever imagined. That you could have something this powerful just literally on your laptop, and we won't get into that now, but we'll certainly touch on the future of these models and where they're going to take us. But I want to get into about Gooder and hear what you're working on. Tell us, you determine the order. Do you want to talk about Gooder and then go into predictive versus generative AI, or do you want to start with predictive versus generative and then talk about what Gooder does? I'll leave that to you.
Well, we got to understand what predictive is, because Gooder is a solution for predictive AI use cases more so than generative. But and it basically comes down to, let's plan the use of this machine learning model, this AI initiative, so that it's valuable. Let's actually forecast how much value. If you're not measuring the value, you're not pursuing value. So I'll come back to that, but let's differentiate between predictive and generative. The two very much work together. I'll talk about that. But predictive is where you're using the technology to predict for each organizational element. So a customer who's going to click, buy, lie, or die, a healthcare patient, whether they're going to have a positive or negative health outcome, a transaction, whether it's going to turn out to be fraudulent, all this predictive maintenance kind of things I've already been alluding to, which train wheel is going to fail, which machine in a factory, so that you can preemptively perform maintenance on it, this kind of thing. So prediction is the holy grail for improving all the existing large-scale operations of organizations across sectors. That's why it's been in use for decades. The sort of classic original cases are for credit scores. So who's going to turn out to be a good versus a bad debtor, and fraud detection, and targeting marketing. So, it goes way beyond that. So basically any fairly large-scale operation, one of the last remaining points of differentiation between corporations is going to be that efficiency and effectiveness by virtue of improving these decisions about who to contact, approve, test, mail, warn, investigate, incarcerate, set up on a date, or medicate. And these things are all literally decided on based on those predictions. Prediction is the thing that informs and improves all those decisions. Lots of email is spam and lots of mail is junk mail, but we're going to decrease those error rates. We're never going to make it perfect, but significantly decrease, which has dramatic improvement on the bottom line. So that's the value proposition of predictive AI. So it's still just machine learning is operating on a different level. So instead of predicting for each individual, what should the next word be as the system is writing this paragraph, it's what's the chances that this individual customer is going to cancel their subscription, right? So it's operating on a sort of a different level, but still prediction nonetheless. And we use the word prediction even if we're talking about something that's not literally a prediction of the future. It's just an unknown. So is this transaction fraudulent? Does this healthcare patient have this diagnosis? You still use the word predict. It's just the English language. We're trying to ascertain an unknown. So these fields very much need each other. Right now, generative and predictive are very much bifurcated. The hype over generative is much more sexy. There's no question about that. It's really, really cool. It's unfortunately a little bit too easy to anthropomorphize. So there's a lot of hype. There's a lot of mismatched expectations. There will be a bubble burst, but nobody knows when because of that hype. And yet it certainly has lots of value, certainly for first drafts and retrieving information from large stores of data. There's so many ways that you can apply generative. One of the big questions, though, is reliability. So if you're having an automated chatbot supposed to provide information with the ease of, let's say, the English language, right? Any turn of phrase, the way we humans use informal language and metaphors and all that stuff, it does great with that. It's amazing. And if you want it to attack a problem of the scope of, let's say, it needs to deal with 7 pages worth of data or rather information. So you've kind of written up some FAQ that it's supposed to be able to answer questions about. And the magnitude is 7 pages, maybe 10 pages. It's going to do really, really well and may easily be reliable enough to unleash it onto the public and general consumers. But with the much more ambitious projects down the pipeline, where you want it to be able to answer questions from information across the internet or tens of thousands of documents or this kind of thing, there's a real reliability problem. And the antidote to that, I just published a Forbes article on this yesterday, is to use predictive to put a human in the loop where it's needed. And we could potentially realize, say, 85% of that often audacious promise of autonomy, where the generative AI system runs on its own with no human in the loop, maybe 85% of the time. And unfortunately, maybe 15%, we have to use that expensive human to audit it or consider before it goes to the end consumer. So that's one of the ways these two fields can very much marry. And I think that they very much need each other. I mean, in a nutshell, generative is extremely easy to use, but perhaps harder to use well in the sense of deploying it for enterprise to establish concrete proven value. Whereas predictive AI has so many use cases that have been established for decades. It's a well-defined value proposition in its deployment. Has a great track record, but it's too hard to use, right? We have to deal with probabilities and triage essentially and formalize that. It's actually not rocket science. The learning from data is the rocket science part, but once you've learned, all you're doing is making these predictions. But still, it's quantitative. It's outside the scope of most business professionals. So if predictive's too hard to use and generative has a reliability problem, the solution to both those problems is to integrate the two. Right? So we can make predictive accessible with a chatbot, which we've done at Gooder AI. You can go to gooder.ai. You'll see right at the top a couple videos. And one of them actually expands to 2 demos where you're going to see the chatbot pops up and it can answer any and all questions about this view about a predictive AI project. So it makes it accessible. And then conversely, as I started to mention, we use predictive potentially as a layer is going to improve and resolve that otherwise potentially really deadly reliability question, because generative AI projects in their more full-scale ambition are just simply not going to deploy at all if they're 5% of the time or more they're actually totally wrong or otherwise problematic, offensive or whatever might happen. So I think these fields very much need each other. So that's sort of my overview of the difference between the two.
At the Berkeley Innovation Group, we are a strategy consultancy and AI advisory firm focused on mid-market companies looking to unlock big growth. In contrast to management consultants' typical top-down, hypothesis-driven approach, Big uses a curiosity-inspired, bottom-up approach, leveraging customer insights to drive strategy co-creation. Learn more about our approach by downloading our ebook at biginnovates.com/ebook. Now, back to the show. Welcome back, everyone. We're having an engaging conversation here with Eric Siegel, talking about getting to the history of machine learning and how it applies to the misnomer, if you will, of AI. And then really exciting to understand the difference between predictive and generative AI. So, Eric, I want to just kind of repeat for understanding and let you add any color to that. But the predictive AI, you said it well, is that ML is the next word. So when you're typing in your Gmail or you're texting and it's telling you the next word, that's machine learning. The predictive AI is beyond next word to outcomes, is the word that I would add to that, predicting in a more holistic sense.
Yeah, and it's outcome on a different level. It's for the organizational element, like the customer. Are they going to click, buy, lie, or die? So, which directly informs the treatment to take with that individual.
Yes. And then getting on to generative. Yes, you're right. There is hype. It is a bubble. It will burst. When? That's the $1 million question. But in this case, when you talked about the reliability of Gen AI, is that akin to just the term hallucinations that many people use, or is there a nuance between hallucinations and this lack of reliability?
Yeah, well, lack of reliability goes a little bit beyond hallucination. So hallucination is a word that just refers to when it gets something wrong or kind of makes something up. It's a misleading word because it's always making stuff up. It's just trying to figure out what the next word, or more specifically token, be. And the fact that it's right as often as it is quite amazing. But there are other things that it can get wrong besides just sort of stating something that's factually inaccurate, right? It can also be offensive. It can get off the intended topic. It could divulge sensitive information that it wasn't meant to divulge to the user. If you empower it to conduct certain transactions, like financial transactions or changing flights, right? It could do something wrong there. So, there's a lot of things that can go wrong with, depending on the ambition and the sort of the project and the power that you're willing to give to this automaton known as a computer. So that is to say, hallucinations is sort of just one place where things can go wrong.
Very important. And so I love that you talk, and we'll link to your article in the show notes, but this idea of keeping humans in the loop is something that's vital just with most technologies. If you've driven Tesla's self-driving feature, I wouldn't want them to take away the brake pedal just yet. So this idea of keeping...
Yeah, I think there's a good analogy there with self-driving. I think the hype there, certain particular players in the field of autonomous vehicles are very much egregiously overhyped, around the corner. It's the same thing. You see a large language model, you interact with a chat, and if anyone listening hasn't tried chatting with a large language model like ChatGPT, what are you waiting for? You've got to try it. It's incredible. And then it gives you this sort of seemingly human-like aura, and it's very easy to assume, therefore, it's going to be able to do everything, or very soon will. Similar with self-driving, right? So driving assistance that's out there in a wide scale now is incredibly unprecedented and amazing. But that's still a much bigger distance than you may realize from allowing it to be unleashed. On the other hand, we want to unleash systems, especially if they're not huge, heavy robots going through our streets of children. But in general, we do want to unleash. We do want automation. That's what computers are for, right? They're to do things. Before we start recording, you told me about your, you made a joking reference to your robot vacuum cleaner, right? We want machines to do things for us without us in the loop. That's the efficiency, that's the savings. And there's a lot of places where you can do that, right? So every time you use your credit card, a fraud detection model makes a decision automatically on the fly, very quickly, about whether to authorize that credit card charge based on its prediction of how likely it is to be fraudulent. So there's plenty of places where we can release it automatically. I guess my bigger message here with the ambition and intention that you hear of what generative AI and large language models should be able to do is that you're giving the machine a certain amount of power, and the mistakes become more consequential, and you're giving the machine a more ambitious project scope, which means the mistakes are going to become more prevalent. And that's where we could potentially enjoy the often audacious promise of autonomy to a good degree by putting that predictive layer on top of it and bringing the human in the loop, not all the time, but some fraction of the time.
And that is the challenge, is where do we allow autonomy and when do we invite humans into that? Because we won't realize the scale and the advantages if every process has a human observer or participant in
right. People are too slow.
I'm just looking at the Gooder website. You made an interesting comment that got me thinking, in this idea of data scientists are good at evaluating their outputs and their models, but they're not great at validating them. And is that like a key value proposition in terms of what Gooder is providing? And if so, can you go a little deeper?
Yeah, that is the key value proposition, the difference between evaluate versus evaluate. And this is where we're going to get a little into the weeds, but most people, you'd be fascinated to know, that fraud detection is out there and it's helping protect your credit card transactions. Sometimes, though, inconveniencing you, but that's the price we pay. With a false blocking of your transaction. We know all of these the way marketing is being targeted and the spam detection in your email, which really is critical and helps so much. But the way these projects are run, and this is all predictive AI or predictive analytics, is that the data scientist makes the model, right? They use machine learning software to learn from the history, right? From the labeled training examples. Great. So how good is the model? So whoever's in charge, the business stakeholder, the customer of that data scientist, person in charge of the operations meant to be improved with a model, that person wants to know, hey, thank you, data scientist, for making my model. How good is it? And then the data scientists almost invariably give a technical answer that doesn't help the business at all understand the potential value. And these are the performance measures, what's called evaluating the model. This is the evaluation, are things like precision, recall, F-score. Their favorite one is probably area under the receiver operating characteristic curve, although you won't usually hear that. They usually just call it AUC. And all of these metrics tell you that the model's better than guessing, which is often the best we can hope for anyway, right? We don't have a magic crystal ball. Predicting better than guessing is generally more than sufficient for driving an improvement to the bottom line. But it doesn't tell you anything about what improvement to the bottom line. It tells you it's better than guessing and potentially valuable. It doesn't tell you how valuable. What we want is the monetary performance. We simply want to know how much money will this model make if we deploy it to target our marketing or to target our retention efforts based on predicting which customer is going to cancel, or target our predictive maintenance in the factory. Any and all these operations, we want to know, how does this affect the bottom line if we act on the predictions, the probabilities generated by this model? And data scientists generally don't have a way to do that. So that's what we're doing at Gooder AI. We turn it into KPIs like profit and savings. It's very straightforward, almost too on the nose, right? So data scientists who've spent decades being like, oh, we love our technical metrics. This is our comfort zone. Like, their money, that's so gauche. That's so on the nose, right? And yet part of the problem is that the business side stakeholders give too much credit and power to the data scientists, kind of like we tend to do with physicians. We're like, oh, the physician's the authority. They're the expert. They know everything. They know what's good for me. And then if you're anything like me, then over the decades, you trust doctors less, in the sense that you give them less authority and you grant them with a lower vision of knowing everything, right? You realize there's real limits. And right now, stakeholders go to the data scientists, like they kind of delegate the entire predictive AI project to data scientists. But no, this is not a machine learning project. It's a business improvement project that happens to use machine learning as a tool necessarily, right? So let's gear the project, drive the project towards business value. And if you're not measuring business value in concrete, straightforward lingua franca of business like profit and savings, then you're not pursuing business value.
And I think you touched on something that's important. And I bring my background of design thinking in, call it human-centered AI, in that sense that nobody wakes up in the morning and be like, wow, I just cannot wait to get another algorithm today. They want the business outcomes, right? That's the job to be done in parlance. And so you talk about accuracy being the most common measure, but let's dive more into how that savings is realized at the bottom, or the performance and the improvements, how that trickles to the bottom line. Can we dive more into that?
Yeah. So that's the thing, is that you need to involve, you can't just be in your kind of isolated vacuum cubicle and say, hey, look, this model predicts better than guessing. It has this precision or recall. If you want to estimate its potential business value, it depends on how you're going to use it, and depends on practical business factors surrounding that deployment and the project. So for example, fraud detection. If you're a bank and you need to use a model to decide on the fly whether to authorize each transaction, Well, if you have what's called a false negative, which means you allow a fraudulent transaction to go through, then it's going to cost you. You may be responsible for the full charge. It could be $1,000 transaction, $500, right? So that's the literal cost of a false negative. Whereas the opposite is also true. If you have a false positive and you say, this is
fraud and you decline my transaction.
Yeah, you've inconvenienced the cardholder, and that tends to be less costly, but you can estimate the monetary cost. The industry tends to say it's around $100, right? Because if you get inconvenienced too much, you're going to start using a different credit card in your wallet. You may cancel this card entirely, what have you, right? So for all of these different use cases, should I perform predictive maintenance here? Should I offer a discount to this customer who might be at risk of defection? All of these cases can often be put in terms of the difference between false positive costs and false negative costs. Because again, we're not going to have a magic crystal ball. We're going to predict better than guessing. And we're playing, business is a numbers game with these probabilities, these predictions output by predictive AI. We play those numbers games more effectively, tip the odds just a bit in our favor, and in that way, drive a tremendous improvement to the bottom line. To estimate and measure that performance to the bottom line, it does often come down to sort of very particular arithmetic involving the prevalence of those errors and the outright costs referred to as false positive and false negative costs.
So at a high level, if I'm a financial services company and I'm trying to move beyond machine learning to look at examples like, just as we talked about, predictive AI, saying nothing of adopting generative AI. That being said, it's not just those technical metrics that I am now able to judge this project on, but it's actually, has that cost of a false positive gone up or down over time through the use of this technology?
Right. Well, and it's not necessarily that the cost of each individual error is going to change, but you want to make the errors less often with the model. If you make them this much less often in this case for these particular transactions, et cetera, so roll up all the particulars. You have a whole bunch of data over which to evaluate, that is to say, test. And let's not just evaluate, but let's valuate, that is to say, measure in terms of monetary value, like profit and savings. Then you do the arithmetic, you roll it up, you do the math, and you're like, hey, if we start doing fraud detection with a model that has this kind of performance, we're going to save $40 million a year, right? So that's the math. If you don't do that math, if you don't visualize it and make those estimations, then you're putting the business stakeholder, and by you, I mean, let's say you're the data scientist, you made the model, you're passing the baton, you're saying, hey, look, I made your model, go deploy it, go deploy this fraud detection model, whatever it is, change your operations with these predictions. That's what you're saying back to your customer, the business stakeholder. And then the stakeholder said, well, how good is it? You're typically putting them in a very uncomfortable position because you're not giving them any estimate of the monetary value. And then for them, they have to decide, well, should we deploy it? This is a large scale operation. Because it's such a large scale operation, right? That's where we have the potential greatest wins, but we also have the highest stakes if we're trying to change anything, and a lot more operational complexity by making a change. And now you're leaving them, they have to decide between a shot in the dark, right? Like if I built a rocket ship and I was like, go launch the rocket, shouldn't you stress test the rocket in its intended usage according to the KPIs that matter before you launch it? Learn how to steer the rocket towards better performance. If not, the stakeholder will scrub. And in fact, that's what happens. Most predictive AI projects are scrubbed. Only a small fraction of them actually successfully launch. Now, a lot successfully launch because a small fraction of a lot of projects is a lot. But the track record is dismal and stands to be greatly improved.
And so we talk a lot about leadership teams and their lack of comfort with just turning these models loose, if you will. And certainly there's operational guardrails you need to put in place to ensure that the model doesn't go, create a business risk, shall we say. But you're taking this a step further and saying that, or am I making a correct assumption to say that when you can quantify the benefits, does that roll back to helping leadership teams as they evaluate whether to deploy these technologies?
Yeah, well, it has to. I mean, it is. It's a huge breath. It's a breath of fresh air because all of a sudden they're given visibility into what they care about instead of this sort of feeling that, hey, the data scientist says it's good and it's got this area under the receiver operating characteristic curve of 0.837. Wow, I mean, it's predicting a lot better than guessing. It kind of makes sense, right? It makes sense that we could more effectively target our predictive maintenance or whatever the operation is. It makes sense. So there's sort of this pressure. You got to do it. The competitors might be doing it. And yet, they're going to very quickly start coming up with reasons to not deploy it. They're outside their comfort zone for good, and they shouldn't be. You should be comfortable as a business person and as a business in the sense of pursuing specific value that's been estimated in a concrete way. And this applies not just to the first time you launch a model, but then when you refresh it, you update it, you change it. And any time that you're making a decision about deploying, redeploying, changing the deployment, maintaining the current deployment, it's all the same thing. Any decisions about planning or updating the use of predictive AI needs this kind of business insight and transparency into the potential business performance, in terms of monetary performance.
Is this a paradigm that's been used in previous generations? So if I was deploying a SaaS product, just as an example, right? Would I be able to have this visibility? And are you just transporting that visibility to the next technology? Or is this fundamentally a new way to look at valuing technology implementations?
Well, this is new, but it's very much specific to predictive AI initiatives, right? Where you're essentially deciding which individuals should we treat? Should we investigate, incarcerate, set up on a data Medicaid? Should we perform predictive maintenance? Whatever the operation you're driving and deciding about on a per case basis with a model, right? This is very much a specialized. So this is not the rocket science part. It's not the learning from data. It's not the machine learning algorithm. It's what we have at Gooder AI, our Gooder AI product represents a new category of machine learning software that augments the actual core learning part to then guide the business in how, whether, which, and how to deploy the model, so that with confidence and a meaningful estimation of performance, you can decide, is it good enough? Should it be deployed? What should we expect in terms of value? And exactly how should it be deployed, right? Which often comes down to that sort of decision boundary, right? How many transactions are we going to block as potentially fraudulent? The top 0.5%, the top 0.75%? When talking about tens of millions of transactions, that's a big difference. You're not going to block more than 2 or 3% by any means. It's usually going to be a small sliver, but there's still a lot of room for variability. So there's this big knob that needs to be turned for all these projects, and that needs to be turned with visibility, with business visibility on, right? And that's what we're doing. And it is totally new. We call it machine learning valuation. And I've been in the field of machine learning for more than 30 years, and somebody's got to do it. We're first, but we definitely won't be last.
Yeah. So with that being said, then what is your target, or who is your target customer? Is it the data scientist, or is it the CFO? Is it just to help the data scientist communicate with others in that C-suite? And I want to understand Gooder, but I also want to understand the broader ML AI adoption curve in general. What's the Trojan horse to get into these C-suites? Is it sort of a frontal assault? Is it a burning platform? Is this a nice to have? Give us that lay of the land, if you would.
Yeah, sure. No, that's a great question. First of all, the customer is both. The stakeholder person in charge of operations meant to be improved with machine learning or predictive AI, and the data scientist making the model for them are both facing an existential crisis, which is this project going to work? Will it actually get deployed? Do we have visibility? We're going to achieve proven value. Of course, if it doesn't deploy, which is usually the case, there's no value, right? You don't get value. You don't get an improvement to operations if you don't change operations with the predictive model, right? So that's the deployment. So facing that existential crisis and the gap between them, they don't speak the same language. There's this sort of awkward gap between the expertise of the data scientist, who's not trained or equipped to talk in terms of monetary value, and the business stakeholder feel trusting of the data scientist, and well, they should. The data scientist has been trained and knows their stuff technically, but doesn't know how to translate that into business value and put it in business terms that are transparent to the business side stakeholder. So what that means in terms of our product is that the first user is the data scientist, and they're already doing the number crunching. They've already got this held aside test data to evaluate their model. Now use that same data to evaluate the model by using our product, Gooder AI. And then once they've set it up, the interface is totally accessible. I mean, it often comes centrally down to a two-dimensional chart. And one dimension is that main business decision about deployment. How many, right? How many transactions, the top 0.5% of transactions to block as potentially fraud? How many customers to target for marketing who are predicted likely to buy if we target for marketing? The top 20%? How many to target for retention if they're likely to defect? How many, cases should we trigger a costly predictive maintenance on the factory floor versus not, right? Where in that case, the false negative can be basically an unexpected down time of a machine could be vastly more costly. So all those decisions, well, where do you draw that, what we call decision boundary? That's the X coordinate. And then the Y coordinate is money, 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 money. Crazy. It's so on the nose, just doesn't exist. Data science arsenal. Now, there are some rare exceptions where people make, but in general, if you want to do this, it has to be bespoke. It's sort of the definition of a startup, right? If people are doing it in Excel. But in general, they're not, because even if they do, it doesn't solve the business problem. It's got to be very specialized, off-the-shelf solution like the one we've created, because you need to be able to interact with it. It needs to be dynamic. The business factors that are subject to change and uncertainty, you need to be able to play with them and get a visual sense of how big a difference they actually make and whether the uncertainty you're working with is okay. So anyway, once the data scientist has set it up, it doesn't take a PhD to move a slider, right? Or in order to understand a two-dimensional chart. And now it's finally telling them what any business stakeholder who's in charge of operations is meant to be improved with a model. They're not looking at that two-dimensional chart. They're not looking at anything. And in general, today, they're not looking at anything, right? So that's why it's a shot in the dark when you deploy these models. That's why they often fail, or even more often don't get deployed at all. Because who wants to make a shot in the dark? I think the industry's gotten really, really adept at sweeping these failures under the rug. And by failure, I mean the lack of deployment, which is so prevalent. Right. And when I'm talking particularly, and we've done industry research, I was involved in 2 rounds of industry research, and many others have as well, where you ask data scientists, of all the models that you generate that are intended for production, that you developed with the intent they would be deployed, how many get deployed? And it's a minority. Which is also, by the way, the premise to my second book, came out a year ago, called The AI Playbook, which is about the numbers I'm talking about, the valuation, the metrics, but also about a lot more in terms of the organizational process to get us there.
I love this idea of just enabling people to tell a good story. And in this case, telling a good story is monetizing it. But at the end of the day,
yeah, and I think you're nailing on the head there. And the word that's doing the extra heavy lifting there is good, because people are telling a good story in a certain sense of the word, but not truly good. So the good story that we hear that's prevalent now is this technology is awesome.
Right.
Machine learning works. It learns from data, and then that pans out. It works well over unseen cases. Right. So it hasn't just memorized something particular to the training examples. It's actually discovered something that holds in general. That idea of something that holds in general, that is the concept of learning. So machine learning works. It's awesome technology. It's one of the last remaining points of differentiation. All the stuff we've been talking about, that tells a good story. But if you want to put good with a capital G from a business standpoint, the story has got to also include business visibility into both what it means to deploy it and the actual business value you're going to get from it.
I think that's so well said. So putting a bow on that part of our conversation and looking ahead, a company like Gooder, an offering like Gooder in terms of monetizing or calculating that valuation, if you will, of that effort, is that risk becoming a feature of another product? Or is this something that can stand up and expand and be a broader piece of that stack?
No, that's a great question. And, we believe that this is going to be a new category of software that has to be part of the ecosystem, machine learning software solutions and data warehousing and everything in general, because What's not going to change is that there's a lot of competing machine learning software solutions, both open source and paid, and a lot of different competing machine learning methods. We talked about neural networks, decision trees, logistic regression, XGBoost. There's all different kinds of ensemble models, and there's pros and cons to all these different methods, and there's pros and cons to all the different software solutions that embody those methods. So that's the big toolkit that exists now. If we're going to also move and integrate into the model development process the act of evaluating the model in terms of its potential deployment scenarios and what if scenarios around the business factors, that's very much requires a specialized GUI that's interactive. It's not likely to go open source because open source doesn't do well with GUIs. And it needs to be a solution that operates no matter which of those other machine learning solutions you're already using or may use in the future, as far as across the different methods and software packages. So that's what we've done. We've got and that's what we believe that the ML valuation space is going to always consist of, is something that operates universally, regardless of what the other tools you're using is.
Well, it comes back to the value proposition that Wise recently offered, that Google acquired, is they were not the first by any means to offer this cloud-based security, but yet they made the interface so easy that everyone adopted it as the de facto. And then if you look at it from Google's perspective, they just bought a Trojan horse into everyone else's cloud, whether it was Azure, AWS, et cetera. And so from your perspective, clearly anyone starting today does not have the firepower to keep up with the established LLMs. That's not a race you're trying to win. And Sam Altman and others have admitted it's a commodity. It will become a commodity market. In that respect, is there an opportunity for you to be that Trojan horse, if you will, that's model agnostic and can see into all these different businesses? And it, to me, it speaks to a blend of software, but also you're certainly unseating a level of professional services that could charge a lot of money for this kind of analysis.
It's true. So most of the interest we have from consultancies so far, and we're very much an early stage startup, less than 2 years, for forging what's really such a new change the paradigm to the model development practice. But most of the interest we're seeing so far is from more smaller or boutique size analytics consultancies. But we think that with all the consultancies, all the service providers, this is only going to help, right? It's only going to be a win-win-win when they can deliver not only the model, but a clear view into its potential value and all the deployment options so that these informed decisions can actually be rendered about which modeling project to greenlight for deployment, and within each project, which model, whether to deploy it, and in what way, how to deploy it. So the Trojan horse analogy, and I know you asked that earlier, one way to look at it is that if a data scientist gives a hoot about their customer and it could put their feet in the shoes of their customer, their stakeholder for a second and say, oh, look, I care about the monetary performance and other potential competing KPIs as well. And I want to be able to give visual accessibility to that and understanding in concrete terms, no hand waving, right? But nothing shrouded by something overly technical. They can take their model, put it into this solution, and then have something to share that's totally accessible and understandable. Now, that might be a little bit of a big if, right? Because right now, data scientists are getting their salary. This is the way things have been for decades. So there's inertia, right? They don't necessarily have a great incentive to change. They have some incentive to change. Now, so I guess what I'm really getting to is, right, who are the early adopters, right? And that's what we've got about a dozen companies using the product right now. But finding those early adopters takes some doing because your typical data scientist, in my opinion, they care for sure. And they're certainly frustrated periodically when their models don't deploy, as is usually the case. It's frustrating. You see, I've been running a conference since 2009 called Machine Learning Week, first week in June. The conference is in Phoenix the first week of June, and very much going to be a combination between predictive and generative AI. You can go to machinelearningweek.com. But with that and just all the talking shop with colleagues, and then just also certain forums and such, you hear over and over again, oh, why don't they deploy the model, right? It's very frustrating and disheartening. And that's the opening story in my book, The AI Playbook. I've gone through that. My wife is a data scientist, has gone through. Everybody goes through it, and it's frustrating. Like, oh, they didn't use my model. Am I actually producing any value here?
Right.
And then it's frustrating. And then they get their paycheck at the end of the week, and they forget about it. Right? I mean, and there's a certain degree to which data scientist roles are a luxury position, and they will because they're a certifiable expert for sure, even if they're not delivering nearly as much value as they potentially could, in some cases zero value. There's not a great incentive to change because there hasn't been enough social proof. So that's what we're up against as a startup, right? So that's just sort of a bootstrapping issue, and it starts to become more recognized and proven cases, and then quickly, this is if you were an investor, this is what I would be pitching, right?
Yes. What you say is so true. And it's that inertia is one of the strongest forces in the universe, and overcoming that's the challenge. And you touched on something else that I sort of sarcastically say, long-term thinking in any organization is the next paycheck. And how do you move them to actually, because you are asking individuals in their mind to put that next paycheck at risk, and the upside is not always there to justify that risk. And I think it's just being aware of that helps people. And that's why one of the pieces of advice I always give my students is, when you're starting a company, oftentimes it's more valuable to know who your customer isn't. How can you get people to disqualify themselves earlier in that funnel to obviously save you resources, but allow you to focus on the people who are those true believers?
Mm-hmm, mm-hmm. That's a great point. Yeah.
So final thoughts here, Eric. I always ask my guests the same question. And that is, what is one thing that we haven't talked about that you think our listeners would benefit from knowing?
I would circle back to my more recent book, AI Playbook, because, I've been focusing a lot on what we're doing with Gooder AI as far as metrics and visualizing model deployment and augmenting model development in that way so that you get these projects to work. But there's a bigger framework that I present in the book I call BizML, Business Practice for Running Machine Learning Projects, BIZML. That's actually the website for the book, bizml.com. And it's a 6-step practice that ushers the project successfully through to deployment and engenders deep collaboration on a semi-technical mutual understanding between the data scientist and the stakeholder, right? Only one of those 6 really focuses on the metrics, what we've been talking about mostly today. But all the sort of planning and prepping and value-oriented, deployment-oriented project planning, rather than focusing on the core technology, focus on the business outcome and the operational intention. So that's sort of the theme of it. And so more broadly than just metrics, that's what's missing. It's just that within that, the place where there's an opportunity for a startup, the place where there's an omitted missing ingredient in terms of software solutions, that's the metrics. That's what we're doing at Gooder.
Nice. Well, you've already answered so many questions about where people can find out more about you, but we'll put the links in the show notes because there's a lot to digest here. And like you kind of joked earlier, I hope you've had a dialogue with these LLMs, and it's just fascinating to understand what we can do. I'm just in my own workflows to really understand it's not just I get a little bit faster at this one thing, but it's the psychological piece of reevaluating what I do over time. And I found myself getting frustrated that at times I can't keep up with everything that I know machine learn or the LLMs can do for me, right?
Yeah.
And that I think is the next conversation that we'll probably have as the technology evolves. But for now, let's put a bow on this. So, Eric, I want to thank you so much for taking the time, and best of luck with Gooder.
Thanks, Jeff. Thanks for having me on.